Well, hello again. Here we are. This is RL4 video 7, where we're going to look at the q-learning.gd, but I thought we'd start for that. Quick review. So the simple neural network, we set up this network that actually contains our information. Important function is this forward function. This is the one that does the computing once we give it some information to compute to, compute the new weights and biases for the network. That's where the information is stored. We don't have a Q table. It's stored in this neural network. So so this function is used by the DQN agent, and the big thing it needs is when it's training, it needs to get it gets these experiences from the agent q-learning.gd, and every 32, in this case, depending on the buffer size, every 32 experiences, it actually does the training on the agent. And the other important function here is where it updates the outer layer from the output layer from the hidden layer, and the hidden layer and from the input layer. This is a very simplified form of back propagation, like that forward function over in the simple neural network is a very simple form of the forward computation that's done in any DQN agents, excuse me. So anyway, so we're looking for, where are these experiences? Where's this batch in the replay buffer experiences? That's up in q-learning.gd. Let's go there. So to start with, just a quick overview. So this is in the ready function, this is where it chooses NN learning, and here we create a DQN agent object that we can use. Here we do the training. We'll get to that in a minute. Once we're done with 1,000 episodes, depending on how many you're set for, then this function takes that DQN table, the neural network, the biases and the weights, and converts it into a Q table that can be printed out down here and saved, so we can use it with our player.gd. So let's go down now to the train, which is where the last bit of action is happening. The train.gd is going to start out looking very similar. So we set up up here. This is helping with troubleshooting, actually. So here's where it set up the episodes, where it starts a new episode. And the rest of this is where it actually does the computations for a new episode. And here's where it gets the action. What is the next action? And notice it needs to go to the DQN agent to do that because it's looking for an array, a one-hot array. And again, it gets the next state, finds the reward, and this word part is going to look really the same. So there's the first part of the reward, depending on which cell I'm in, which state I'm in. And this one is some rewards on, we're trying to keep it from going back and forth between two states, penalty and for going back to a state it's been in before. Here's where we're trying again to keep it from jumping too much. And finally, here's where we're saying if you get to one of those two states, 12 or 0, that basically go off the end each way, then that says you're done. And then I'll get to that in a second, another part in a second here. And then it says if you get all 3 coins, big reward and you're done. This little bit right here is not in the other 3 methods. It's in this one because it has this method has a habit of producing very large negative scores, and I just wanted to cut them off. So I put if it's less than -40, quit. Okay, then here's where it encodes the next array. Excuse me, the next starting state, next state, excuse me. This is the important part. Here's where we add to the replay buffer. the state array, the action, the reward, the next state array, and the done. That's what it's looking for in the replay buffer. And then this little bit here is what says every 32, our case right now anyway, every 32 times you do, every 32 state action steps, go train the agent. And here we go, and we update the reward again. We keep the total reward. And this is actually used for, down here, it's used for troubleshooting again. I'll get to that after a bit. Episode number again is also has to do with troubleshooting. Same with this line, troubleshooting. And this is where we update the epsilon so that we can gradually do more exploitation and less exploration. And this was another key little function of what it does is saying that every 10 in this case episodes that we run, let's go ahead and update the target network. And the functions back over in the DQN agent where it makes the target network equal to whatever the current Q network is. Okay, so, and then here's where we get the next state. Whoops, sorry. And that's it for the DQN agent main training function. The rest of these are support functions. Get next state, generate the Q table up there, and ready function talked about once we get the neural network trained, we need to convert that into a Q table. That's what this function does. We're down to there, and this is where it builds it. And here's the one hot encode and one hot decode functions. We don't use the decode function here in agent q-learning. We do use it over in the DQN agent. Okay, so that's it for the looking through this function, this excuse me, set of functions for NN learning, for DQN learning. One of the things I want to point out is this is actually much more difficult to get right than is the other three. You really got to tweak carefully with the hyperparameters and even make potentially adjustments to the rewards to get anything that's functional. There's currently one that's functional right now, but I want to show you a couple of the problems with it. So for example, here's the last roughly 10 episodes. That's nice. It's coming in a nice big positive number, which is what you'd like to see. But then if you look at the actual, let's look at state 1, for example. State 1, moving left, should be negative. This one should be negative. This one could be positive. This one should be very positive. But notice that, you got to get to the hundreds place before this one ends up being the strategy that's going to be followed. These numbers are too similar across each state, and they're too similar between states. It's fairly easy to tweak the variables so the undesirable states do turn up negative, but I haven't been able to figure out yet how to tweak it so that we get both that desirable outcome, the states that you don't want, you shouldn't be going to, are negative, or at least not very positive. And the one you want to go to is very much bigger positive. It's been a struggle to figure out, and while there's a way to make it work correctly, like I said, this is a winning solution, it's not working right. And I suspect either my hidden layer is insufficient, very possible, or the fine-tuning of the hyperparameters and the rewards needs to continue to be messed with. And it's really an interesting game. I find it much more intricate and difficult to tune this one, the DQN agent method, than the other three methods. Okay, anyway, that's it for now. See you one more video. Bye.